Hello. Today we are going to talk about the ultimate Pythagorean identity. Okay. The ultimate Pythagorean identity is, let's see this guy, sine squared theta plus cosine squared theta equals 1. You can also sometimes see it as sine squared x plus cosine squared x equals 1. Same thing. And we proved that using right triangle trigonometry in the intro to the unit circle video. We just used the Pythagorean theorem for it. I wanted to point out a few other things quick. So here we have the unit circle. And I've labeled my x-axis here as x is cosine. X is cosine, x is cosine, y is sine, y is sine. On the unit circle, all the time, all the time. All right, your turn. Ready? Just kidding. But it is a very handy song and it gets stuck in your head and it will help you remember that x is cosine and y is sine. Let's do this application problem down here. It says find cosine of theta when sine of theta equals 3/5 and theta is acute. So I just need to find the value of cosine theta. Notice how it's not saying find sine. Notice how it's not saying find theta, right? It's saying find cosine of theta. So that's very nice of them because I just want the value of cosine theta, and we can use the fact that sine and cosine are connected using the Pythagorean identity. So I'm just going to sub in sine theta. Sine theta is, let's start with the identity. Sine is 3/5. I'm going to sub it in. Cosine squared theta, we don't know what that is yet. And I'm just going to write a smart version of 1 here. I'm going to write it as 25 over 25. Because the reason being that I know I'm going to have to subtract that 9 over to the other side, right? I'm going to get 9/25. And I know I'm going to have to subtract that 9 over to the other side. So I'm going to rewrite this as something that I can add or subtract very easily. And I'm going to do that. And I would get 16 over 25. You can just treat this like any other equation, right? In order to undo the exponent squared, I would just square root both sides. And I would get the there we go. I get the cosine of theta equals plus or minus the square root of 16 is 4, square root of 25 is 5, plus or minus 4/5. At this juncture, you may be wondering, which one do I select? If you look at the original question I used, the sine of theta equals 3/5, right? But I ignored the fact that it said that theta is acute. Now I'm going to go back and use the fact that it said that theta is acute. I am going to look up at our unit circle, right? Theta is any angle that is drawn in our unit circle. And you're always going to start from the center and then draw going out or rotating out counterclockwise. So theta could have been something like this, right? Theta could have also been something like this, in which case theta would be obtuse, right? This would be the point on the unit circle, cosine theta, sine of theta. But why is this relevant? Why am I drawing this over here, right? Because if we think about the fact that x is cosine, y is sine, then x would be negative, right? If I wanted to put this point on the coordinate plane, x would be negative. X would be negative. So that means cosine would be negative and sine would be positive. So if I change this and it said obtuse, right? If this said obtuse, then my answer would be the negative one. I would select the negative version of 4/5. But since it says that it is acute, since it says that theta is acute, I am going to select the positive version. It is telling me to only take the cosine of theta in quadrant 1 when cosine and sine are both positive. So I would pick the positive version. Cosine of theta equals 4/5, and that would be my answer. Okay. An extension here could be to find maybe the tangent of theta, like from this information, right? So maybe they want you to find the tangent of theta. Well, we know that tangent of theta is sine of theta over cosine of theta, right? So if they were asking me about tangent, I would just sub in tangent of theta equals, what was the sine of theta? 3/5. And then the cosine of theta was 4/5. We know that if we're dividing by the same number on the top and the bottom, we can get rid of it, and we would just have the tangent of theta is 3/4. Okay, so the Pythagorean identity, sine squared theta plus cosine squared theta, is extremely useful.